Hello, we are Parisa, Tarahomi, and Yvan from Memorial University of Newfoundland. Today we want to talk about our new and ongoing longitudinal research on the phonological development of Persian. To this aim, we focus on development of prosodic and segmental structures, and with a particular emphasis on liquids, considering the asymmetrical behaviors in the acquisition of L and R. And we had main findings through this work. First, liquids develop later than non-liquids, especially in syllable codas, and we observed optional patterns of R substitution by L. Before turning to methodology, I want to have an overview of the phonological system of Persian. The syllable template for the language is CVC with an obligatory onset and obligatory nucleus. The previous work suggests that Persian has an optional coda consisting of a single consonant or consonant cluster. However, in Tarahomi 2020, building on PIGOT 1999, I propose that final consonants in consonant cluster are not parts of codas. Uh, so they have an special status in syllabification. Uh, in some theories, they are called onsets of empty-headed syllables, while in other theories, they are called extraprosodic. The examples of the proposed syllable template for Persian are provided here. Persian has a stress, and this stress is primary. The primary stress consistently falls on the last syllable with a phonetically realized vowel. The phoneme inventory of language is provided here in this slide. Vowels are not the focus of this study, and moving to consonants, I should highlight the contrast between L and R. Through this work, by L, we mean clear, apical, lateral approximant, like la la la, and by R, we mean tap or flap, with an element of tongue retroflexion or bunching. Some work consider R in Persian as trill, but we have no evidence of R as trill in our own data. This work is a case study of a Persian monolingual boy Arman who was recorded following the tradition of naturalistic studies. The technical detail of the methodology adopted for this study is represented here. But without further ado, let's look at the finding of our study. Based on our observation into 48 recorded sessions, we came up with 9 graphs in total for initial and medial onsets, medial codas, and final codas. The top chart that we have here in this slide and the next two slides represent combined data of FSN. And if you are wondering why we chose these 3 consonants, because they are the only 3 non-liquids that were available with sufficient data for all these 3 positions. And across all positions, they were acquired pretty early and they behaved uniformly. So turning to L, which is our second graph, we can observe that we have many fewer examples in early sessions. However, data suggests that as soon as the child started attempting this consonant, he was successful. And which is different from R. R is represented here in our third chart, and R is different in a few ways. First, R comes in high numbers that are comparable to FSN, so we can say that R is a frequent consonant. Yet, we can account for 3 stages in its development. The first stage that we have here, we can call it as random substitution. The child attempted R, however, his attempts resulting in other consonant production. But from 3 years until 310, we can see that R is pretty stabilized. But the main pattern observed in this stage is L substitution that lasts until 310, which is the beginning of mastery of this consonant in this context. So going directly to the second chart that represents L, we can see that the story for L in medial coda is to some extent different from L in initial and medial onsets. Regardless of lack of data in early sessions, we can see that deletion is the main pattern observed until 3-4. By the age that the child pretty much accurately produced this consonant. And lastly, R in medial coda is represented in our last chart. And again, we can account for 3 stages. In the first stage that lasts until 3-3, child's attempt to produce the consonant mainly failed, resulting in consonant deletion. And we can consider the next stage as the emergence of R, because beside the deletion pattern that we can observe in this stage, we can see that the child could produce the consonant accurately until 3-11, which is the age that the child produced the consonant pretty much accurately after this age. And lastly, we have our final codas, and going directly to L in final codas, we can say that deletion is the main pattern that was observed until 3-3, which is the beginning of the year that the child could master this consonant and produce it accurately. And lastly, we will turn to R in final codas, and R got mainly deleted until 3-3. And from 3-3 to 3-8, we have our second stage. In this stage, the context and the position was actually realized by Arman, and he started producing R in this context by the age by 3.8, which is the age that the child produced this consonant accurately. To summarize the main findings that we had in the previous 9 graphs, we came up with a developmental timeline, which leads us to the main questions we want to address through this work. The first question is that why liquids show a sturdier development in final codas than medial codas, and why there is an optional one-way substitution from R to L, not vice versa. And it's also important to mention that R is much more frequent than L across all positions, yet it acquired later and it was target of substitution through this context.
Moving towards an explanation for the patterns we observed, one of the first things we did is we looked at the acoustic reality of adult L and R in Persian. So you have adult L on the left-hand side of this slide and adult R on the extreme right-hand side of the slide. And in between, what you have is one screenshot of an R to L substitution and one screenshot of an R production, something that we perceived as an R production in Arman's early productions. And what we find is that the child's L productions very much align with what we'd expect with adult L, but when it comes to R, what we find is that while the F1 is higher for R than for L, which is what we'd expect, what we find is much more confusion when it comes to the second and third formant, which tell us something about Arman's not having achieved complete of rhoticity at this early stage. So even if we're perceiving an R in our productions, the R is not as rhotic as what you'd expect in the adult production. And to frame our understanding of this developmental pattern, so remember we have some stages of deletion, some stages of substitutions, and of course stages of mastery. We decided to opt to use the AMAP model proposed by McAllister, Beyond, Inkeles, and Rose 2016, according to which acquisition consists of the mapping of perceptual or auditory categories to windows of articulatory implementation of these perceptual categories. So the AMAP may make some predictions. The first being that degrees of availability and or robustness of perceptual cues may affect the emergence of perceptual targets. And here what we're doing is we're contrasting perception or presumed perception in syllable onsets versus syllable coders, given the basic CVC system of Persian syllabification. And also we're contrasting medial unstressed coders with final stressed coders, where stressed syllables typically will enhance perception a little bit. Another prediction is that degrees of articulatory complexity may hinder the development of segmental categories. And here we have two issues. One is the aerodynamics of R tapping, which does require a fair bit of articulatory control, and also the added complexity of the retroflexion or bunching that comes after that flap that makes the Persian R a little bit different from other taps or flaps in languages like Spanish, for example. And finally, within the AMAP, frequency effects may affect the overall development patterns, but are not necessarily deterministic. And this is what also we see in the data. So the data really verify a lot of the predictions made by the AMAP, namely if we focus on syllable onsets and here on the consonant R, which gives us three nice stages of development, what we find is that early on the child, while he was perceiving a target to reproduce, we have very little by way of deletion. The child had not settled on a stable motor plan until about 3 years of age. And after that, Arman moved to a motor plan that, while it's not very accurate, it offers the child some stability in production. And on this, we also want to add that the substitution to L offers a lot in terms of reproducing the R in speech. You know, what really is missing there is the tapping movement and the retroflexion, but we do have good reproduction of cues, for example, concerning place of articulation and also manner. And one of the things we'd like to do here, and we'll do in further research, is really measure durational differences between R and L productions, just to see if we could have some element of covert contrast in there. Moving to syllable coders, we are relating the pattern of liquid deletion to the low perceptibility of that of liquid consonants in this position, and also we are relating the asymmetry we observe between L and R development in those positions to the same factors that's affecting Arman's productions and syllable onsets. So finally, the fact that final coders are acquired for R a bit before medial coders may relate to frequency, may relate to perceptibility, or may also relate to co-articulatory effects. And these are all questions that we need to address in the future.
To summarize, based on our observation for non-liquids FSN, we found that all syllable positions were available through the observation period. Moreover, according to the development of L and R, we know that in syllable onsets that are the position that favors high perceptibility, no deletion pattern happen even for liquids. In contrast, in syllable codas, that disfavors perceptibility, liquid deletion happen, especially in early stage. Moreover, we observed that R to L substitution was similar across all syllable positions, and we can relate it to articulatory complexity of R. Moreover, the development was a bit slower in medial than final codas. So the main thing to think about is that if it's related to stress, to position, or both. The next steps that we want to take is that we want to compare our findings with other Persian learners. And actually this one is an ongoing project because right now we are recording other Persian monolingual children. Moreover, we want to compare our findings with languages either with similar syllable structure or different syllable structure. And we want to focus on substitution patterns for Rhotics. Furthermore, we want to operate systematic acoustic measurements in syllable codas, either in medial or final, and we want to do additional segmental and prosodic context to consider. We want to look at the development of other consonants in onsets and codas, and we want to also include coda clusters. Lastly, I want to leave you with this beautiful picture that comes from my country beside the language. Thank you. سپاسگزارم.